Hey everybody, it's twins! Yeah, so hello, welcome to Analog Output, and this time we have here two modules. This one is the Barton Musical Circuits analog drum. This one is the Barton Musical Circuits FM drum. These are drum modules. If you're not familiar with drum modules, the general idea is if you want to synthesize a percussive sound, you can do that with a ordinary general purpose synthesizer. You can, for instance, take an oscillator, maybe two oscillators, have maybe a voltage controlled amplifier controlled with an envelope generator that'll give you the sharp attack and the longer decay that's characteristic of percussion. Maybe you have two envelope generators, one of them on the frequency of the oscillator. Maybe you have a noise source thrown into it. I don't know. Stuff like that. You can put together a percussive sound using 3, 4, 5, half a dozen modules, which will give you, a kick drum. And then you can use another 3, 4, 5 modules for a snare drum, and another 3, 4, 5 for a tom, and another 3, 4, 5 for a hi-hat, and so forth. You want to make a whole drum kit, sitting there using up about 30 modules, and that's before you even talk about whatever it is this drum kit's supposed to be accompanying. So, well, if you're recording, maybe you can do those all in like sequential overdubs. If you're trying to do all this at the same time, you're going to need a synthesizer about the size of your house. So the other possibility is you say, well, you don't need a fully featured oscillator. You don't need a fully featured VCA. You don't need a fully featured envelope generator. You just need certain limited capabilities for each, and what you can do is come up with a limited oscillator or two and a limited envelope generator or two and a limited voltage controlled amplifier and so forth, and put those together into a module, a single module, which is a full synth voice containing the oscillator and the amplifier and the envelope generator and so forth, but a synth voice that's specialized for creating percussive sounds. So that's what's going on with drum modules. These are two drum modules that I just built. Let's take a look at them. So these are through-hole boards. Not a very high part count, not a lot of density here. Pretty straightforward to put together. I did make a couple of changes though. One thing is that Barton does use 10 ohm resistors in series on the 12 and minus 12 volt power buses, and this is something that a lot of synthesizer designers do. Others like to use ferrite beads in the same place. I'm not an expert myself, but I've read a couple of articles by Mike Scala of North Coast Synthesis, who does come across as something of an expert, and he makes what I think is a fairly persuasive case that neither 10 ohm nor resistors nor ferrite beads really make a lot of sense in that application. What he does argue for, and which makes some sense to me, is a couple of Schottky diodes in series on the power rails to guard against voltage reversal if you happen to plug it in backwards. Of course, using a box header here with a key, it's virtually impossible to plug in the header backwards unless, of course, the power cable itself was constructed backwards, which is known to happen. The other thing I changed is, for some reason, Barton seems to like 0.01 microfarad or 10 nanofarad capacitors for bypass capacitors on the next to the integrated circuits. And as far as I can tell, basically everybody else in the world advises and uses 100 nanofarad, 0.1 microfarad capacitors there. So I switched those bypass capacitors to 100 nanofarads. There are a couple of other 0.01 microfarad capacitors in his designs which are not bypass capacitors, and I did not change those. Okay, now one thing about the Barton modules is if you order from Barton, you can order the printed circuit boards. You can also order a front panel, but the front panel that you get is not decorated. It's a plain piece of sheet aluminum cut to the right size with holes drilled in the right places, and that's it. And Barton says he's trying to encourage you to be creative and come up with your own design for your front panels. Okay, if you go to Modular Addict and order from there, they have front panels for the Barton modules that are available, which they've created or had created for them. And these are more or less professionally designed front panels with the labels and the graphics and so forth. Quite nice. But those panels are about $20 each, and the undecorated panels from Barton are about $8 each. And I, being the dedicated cheapskate that I am, decided to go with the Barton panels. So then I had to come up with some way of decorating them, and I could just, like spray paint them black and take a silver Sharpie and write on them and get something that looked really, really horrible, or I could try doing something else. What I tried doing was essentially what was recommended by Ray Wilson of Music from Outer Space, where I used a computer graphics program to design a front panel, printed that out on paper, and in the case of the FM drum, sprayed that with clear paint and glued it to the front panel, trimmed it to size, cut out the holes, and mounted the hardware. In the case of the analog drum, which I actually did first, I did something closer to what Wilson suggested, which was that I actually printed out the piece of paper. In fact, had it printed out at Office Supply Place on their color laser printer, and then had it laminated. Problem with that is, first of all, it gave me a choice of lamination thicknesses, and I took the thinnest one, but even so, it ended up being so thick that it was very hard for me to get the jacks on, because the threaded length on the jack is so close to the thickness of the panel plus the laminated label. The other thing is that you get a very shiny, glossy finish with a laminated panel, whereas the clear spray paint gave me a more sort of matte satin kind of a finish, which I preferred. You can get matte lamination material, but they didn't offer that at the office supply store that I went to, so I had the glossy one. I prefer the second one. I prefer it with the paint, although the downside to that is that it's more susceptible to damage than the laminated one. So neither one's perfect, but they're both better than silver Sharpie on black paint as far as I'm concerned. You do have to wire some of the panel components. Not all of them are mounted on the PC board. And wiring panel components is something I'm still getting used to. Takes me a little longer than it really needs to, I suppose, but we're getting there. Anyway, in both cases, the modules went together pretty easily and pretty quickly. They don't just look alike. They have a lot in common, these two circuits, and building one is a very similar experience to building the other. All right, let's take a listen here. Analog drum. And a problem you hear right away, I'm triggering this thing with the key step gate output, and here, I'll hit a key and release it. And you hear a thunk thunk. If you look, you can see the LED flashing twice. There's a little secondary trigger when I release. If I hit the key and then release, it's not very audible, but it's there. So it's double triggering. It's triggering on the gate on and on the gate off. But if I take this gate and I run it into a buffered multiple, take the output of that and put it in, then it doesn't double trigger. Something else I've noticed is sort of an intermittent thing, and perhaps it has more to do with the key step than anything else. Is sometimes I don't get consistent sounds. If I hit a key, I might or I might not get sort of a chirp at the beginning, more or less. The sound varies from one hit to another. But when it's not doing that at the moment, and when I was noticing it before, I tried triggering it with the Moog Mother 32 gate, and it was responding consistently to that. So I don't know whether that's the module or the key step or what. Anyway, this is the analog drum. We've got the frequency set kind of down low. Let's write it down in the bottom. In fact, let's turn up the frequency and see what happens. Now you can set the frequency up quite high, but really the best drum sounds, I think, come from the frequency down in the lowest 1/4 of the range. Okay, and the frequency modulation, or the frequency depth, you can set that down to minimum, turn it up, and you get more of that kind of chirpy thunk at the beginning. Okay, and the frequency decay, again from minimum to a maximum. Amplitude decay, minimum. Up to very long. Now if I take the key step control voltage and turn up the control voltage response, let's take that down a bit. Okay, even at maximum CV, you're not getting anywhere near an octave for a 1 volt change in the control voltage. It's, this is octaves apart. Okay, but you're not trying to play melodies with this thing. You're just trying to get different drum sounds. Let's see, can I turn that down further? There we go. Okay, so that's sort of the analog drum. The FM drum over here. Let's see. We can run the frequency to its range. Now, because this is FM, just raising the frequency doesn't just change the frequency, because you get interference or constructive or destructive interference, or whatever you want to call it, between the two frequencies of the regular oscillator and the modulating oscillator. So that's one of the frequencies, and this is the other frequency. vary the FM depth. Lots of weird things happen. Amplitude decay, again, very short up to quite long. We got the waveform for the main oscillator and for the frequency oscillator. That's interesting. There we go. And again, we can give it a control voltage. Here, if you don't have the control voltage plugged in, it feeds its input back on itself. I mean, its output back on itself with kind of weird and inconsistent results. Not sure that's really very useful. Anyway. Let's see, let's put this over here. As far as that double triggering goes, this is the input stage on the analog drum, and actually it's the same as the input stage on the FM drum. And what happens is you've got an input and then you've got a resistor capacitor that takes whatever gate comes in and shortens it to a short pulse. And then it presents it to an op amp, which is wired up as a comparator. And the reference voltage going in there is coming off of a voltage divider where you've got 12 volts at the top and then a 100K resistor and a 1K resistor to ground. So the threshold for the comparator is only about 10%, about 1% of 12 volts. It's, something like 100 millivolts. And I don't know what kind of pulse heights you get out of the what kind of pulse heights you have going into this thing coming out of the resistor capacitor network. I don't know how much that reduces the amplitudes, but 100 millivolts is a pretty low threshold, I think. And I'm wondering if maybe if you have some ringing going on at the end of a gate, maybe that's enough to re-trigger this comparator to give you a second pulse. I suspect something like that is what's going on. And maybe if the threshold were higher, it would work better, or perhaps it would work better if you had the comparator first and then the pulse shortener. I'm not sure. But something like that, I think, is what's happening here. So that's the Barton drum modules. Interesting, a little quirky, probably some room for improvement in the design, I would think. We'll see how useful they turn out to be. I've got a number of other projects in the works, and they're basically all going to be waiting for me to get a few more parts. So I've nearly completed something I call a proximity wand. It's a controller, a CV controller based on an ultrasonic distance sensor. I have an expression pedal interface that I'm going to be building, and I have something I'm really kind of excited about is I've got a board that interfaces an Arduino Nano to a 12-bit digital to analog converter, and this can be the core of any of a large number of possible synthesizer modules. What I'm really hoping to do with it, first of all, is to come up with a programmable, microtonal capable quantizer module. And I think that's going to be really interesting, but it's going to be a little while because the PCBWay is just now fabricating that board, and it has to get to me, and then I need to get some parts for it. But that'll be coming up in the not too distant future. So yeah, like and subscribe, keep an eye out, and we'll have some interesting stuff coming up soon on Analog Output.